Welcome everybody to Passivhaus Accelerator Construction Tech. We're really excited about today's episode with Steve Hessler from Holzraum System. The Passivhaus Accelerator is a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews, produce weekly virtual confabs with passive house pioneers from around the world, and we elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, video, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. With our co-hosts, Kevin Brennan, Shannon Pendleton, Sean St. Amour, and Mark Willey, we produce Construction Tech Tuesday to share the technical, the technique, and the technology of passive house construction tech. Each week, we welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction and design world to join us each week, and we're very happy you're here with us tonight. Thank you.
Zach?
And happy belated birthday.
Oh, why, thank you.
I think we could forego the mute for a second and give a happy birthday salute to Mr. Zach.
Happy birthday, big guy.
Thank you.
Happy birthday, Zach.
Happy birthday.
Happy birthday.
Thanks.
Oh, you betcha.
That was awesome.
Best happy
Awesome.
birthday ever.
Definitely.
You want to kick us off,
everybody.
Kevin?
Sure. So, guys, welcome to Construction Tech Tuesday. My name is Kevin Brennan. I'm from New York City. I'm a contractor and extremely excited to see Steve's presentation. The technical is out of this world. The amount of information that he's going to pour out onto the screen and the valuable lessons over his career that he's going to share with everyone to not only make a difference in construction, but also push Passive House to that next level. I'm really excited for this. I know myself, I have a few questions, but it's going to be great. To you, Mark.
All right, Kevin, I agree. We were blessed by the run through last night. So my name is Mark Willey. I'm thrilled to be here tonight. Also, the technique that you'll see tonight of lighting up the model and walking you through the virtual phases it's unfounded. The value involved in seeing the project before your very eyes, before you have to perform it, before you have to think about it, and know that everyone in your circle is able to connect and collaborate and add to is truly mind-blowing, and it's what we need more of. Ask a lot of questions because there's tremendous support to answer those questions throughout. So I welcome you to take lots of screenshots and share it with everyone else and create more believers. Sean, over to you.
Well, hello, everyone. So I get excited. My passion is sustainable prefab passive house. And so this stuff just goes right up my alley. And you know what? I'm going to keep my intro short. I'm Sean St. Amour. Happy to be here with all you lovely people. And let's get this started because this is a juicy, juicy topic with lots of good stuff. So Shannon, over to you.
Thanks, Sean. I'm Shannon, coming from the East Coast in New Hope. And I am really thrilled for tonight's presentation because our guest will be a real treat for you. He's going to pull you out of your silos and help you raise the barn together. His education starts with a Bachelor's of Communication Strategies from Penn State, layered with a 5-year apprenticeship as a journeyman and lead restoration carpenter. He started his technical experience as a heavy timber structural designer and project manager, and is a PHIUS certified passive house consultant. Since 2008, he's been combining 3D modeling, integrated project delivery, and building science principles to create off-the-grid, net zero, and passive house projects. So currently, he is the co-founder and model Jedi at Holzraum System, offering over 20 years of experience designing, building, and managing structural thermal envelopes for off-site fabrication and on-site high performance. So get ready to see some parts-based modeling magic and help me welcome Steve and some of his friends. Steve Hessler, glad to have you here, buddy.
Thank you so much. Thank you very much. I'm totally honored
And I really appreciate you guys reaching out. And yeah, so Holzraum System, you know, I think a draw to what we've been kind of doing for the last few years. A lot of it initially came from some of the flashy, you know, beautiful technology that came out of Blueprint Robotics when we sort of set up an arrangement with them. They kind of came in with an outrageous level of investment, and we kind of got lucky. We found out about them when we were kind of tired of doing multiple assemblies, site built, and we started to do some panelization. And so we came across them, and they had been tremendous, and kind of, you know, we worked through and developed some initial assemblies with them, and they were kind of our first like all-in fully fabricated manufacturer. People, I think, you know, really came to know us through them, which was awesome. And we've done some amazing projects with them, and we have had some really great experiences on some of these, you know, sometimes buildings with castles and amazing window packages, and, you know, all passive house assemblies and projects. And so we've just been very fortunate. My partners, which I'll tell you about in a minute, and I have been kind of really blessed over the many years to have projects with pretty decent budgets that have helped us develop some things. But what we really wanted to talk to you about tonight wasn't necessarily the machines and the, you know, the wonderful rapid installations, but it was really about all of the work that goes into any of these. So whenever you see not just our projects, but any of these passive house panelization projects, you know, you usually see panels flying quickly, blue skies. And the only reason that those projects make it to the screen is because that means they were successful in the field, because it's scary in the field and nobody's putting up pictures of the projects that didn't go so well. So what we wanted to talk to you about was all of the work that goes into a successful installation like that, or fabrication and installation. And it's just a ton of coordination and work. And so Holzraum System is my two partners, brilliant partners. Ilka Cassidy is a German trained and born architect, and one of the best energy modelers in the Philadelphia area and probably beyond. I'm super lucky to work with her. Ilka and I met when I was running a design build department for Hugh Lofting Timber Frame, a good timber frame and high performance builder in Kennett Square. And she approached me and said, you know, I think we'd like you guys to build this project. Let's do a project. So we did a couple little projects together. And then I think actually the first one was the last one I ever built with any other architect before Holzraum. And so we kind of developed a really good routine, and we found out about Blueprint Robotics, and yeah, that's how we decided to kind of go from just walls only into some kind of a full panelization installation. The other partner for us is my brother, David, and he is a retired developer and a biologist, and he actually ran a department at Desso, which is, I don't know if you know Desso, it's sort of like on the scale of AutoCAD. It's a French company that owns like SolidWorks and a bunch of different modeling companies in many different disciplines, including biology and planning and everything. So David comes with this kind of crazy developer software head for data, but also he really understands the value of offsite and also of passive house, because David actually kind of designed with his wife and had built the first he was involved in Eco Village, and then he actually built the first off the grid house in Ithaca, New York. So he's just been a perfect addition to what we were trying to accomplish. So we'll get into a little bit more about how everything fits in. What we do, so we have two prongs. We do energy modeling and passive house consulting. Ilka does an amazing job of that. And we also do this thing where project comes to us and they're interested in panelization. We take all of the design intent and we match it up with one of our factory partners. And right now we have two main factory partners on the East Coast, Blueprint Robotics and New Energy Works. And we also have a partner that's mostly for our CLT and CLT hybrids out in Montana, and they are Stoltz Timber Systems. And so what we do is, if it looks like the project is a fit for one of these partners, we kind of walk the client through what are the possibilities. We match up what we think would be the right strategies. And then if we're contracted to do the project and we kind of get a ballpark price and they want to go forward, we convert all of the design intent. I'm going to kind of go through this chart quickly because there's just so many things that need to happen inside of a project. And so what we do is we create this thing called a single integrated manufacturing model. And the single integrated manufacturing model, or the SIMM, it sort of lives in the middle of all the design intent. So if you kind of look at this 1, 2, 3, 4, 1 is like the design intent, which could include architectural, structural, MEP, client wishes, program, position, on the planet, climate, everything kind of rolls in there. And then we're looking at that, and then we're aligning it with the low carbon Passivhaus Detailing. And then we're bringing that in with what the builder is best at. So we're looking at the builder's skill set. We're looking at what they've done before. Are they new to Passivhaus? Are they scared of Passivhaus? Are they doing this because they've gotten burned on Passivhaus, or are they doing this because they want to get into Passivhaus? And that's, so that like every one of these 4 items is just as huge as the other item. And so we're rolling that stuff in, and then we do this really weird thing where we take 1, 2, and 3, and we have to jam it into 4, and 4 is the factory. And so what's hard to remember is that the factory can't just do any assembly, and it wouldn't make sense for them to do any assembly. So we've packaged a couple assemblies that we really like from our experiences with a couple different factories, and tried to find the most efficient and layer purposeful kind of builds. But that's sort of what happens. So what's cool is when we're modeling this thing, the model is this awesome tool and we really like it. And we're going to show you how we've been trying to develop it so that it becomes really a tool for everyone. And we actually hand off the model. But what is really happening is that the model is useless without all of this input, right? So you need all this input has to have quality. So 1, 2, 3, 4 has to have quality in content and also in participant and buy-in, right? To like actual collaboration. And then what happens is, what's really cool is if you look at all these arrows, they're going all over the place because that's exactly what's happening. The SIMM sits in the middle. It's almost like an organ, and it basically is just taking in all of these things and kind of like realigning it and then putting it back out and then bringing it back in. And so over the course of, let's say like on a 4,000 square foot building, maybe over the course of, it depends on the design process, but 2 to 4 months or something on average, that's what's happening with the SIMM model. So the SIMM model starts with a very, very rudimentary kind of, volumetric thing, and it just starts to build out, and then it becomes, as you'll see, kind of the collaboration conversation. So the next thing is, what is a SIMM versus a BIM model? Because a BIM model is also an amazing collaboration piece. And we want you to know that the SIMM in no way replaces the BIM, but what it does is it sort of partners really well with what the BIM is missing. So what the BIM delivers, and this particular BIM representation is actually from Shannon from Sanderson Sustainable Design, and also Revision Architects in Philadelphia for one of our projects. This is a very high level, in our opinion, was a very high level, super detailed out BIM model. I mean, you can see that like literally every single brick in the brick ribbon around the windows, every single window is absolutely perfect. The shop drawings, I know for a fact, came exactly from this model. Timber frames in place, vault ceiling design intent is in place. I mean, the design intent for us to get an idea of what they want to build is sick on a model like this. This is awesome. And as awesome as it is, it doesn't have any framing in it. So like, I couldn't manufacture from this BIM model, right? I would need to, even just to do wall panels, I would need to do some level of interpretation, where in this wall is the air barrier plane, and what is the connection from the concrete to the wall? So there's a lot of fill-in that has to happen before. So the BIM model is really, it's a great coordination piece at a high level, and it also is just beautiful at delivering design intent in a format that we all know, which are plans and specifications and schedules of windows and all that. And a SIMM model doesn't do that. It could, but it doesn't do it very well. And so we don't want to do that. But what we do is we take their design intent and then we create actual manufacturable parts. And the way this whole thing evolved with Ilka and I is that we actually did our first 2 projects with Blueprint Robotics, and we learned really quickly that they were only going to model what they were going to make, right? Which is important. And so when you manufacture walls and floors and roof panels, you need a parts-based model. So a BIM model isn't a parts-based model, although it's a very good parts-based model if somebody gives you the MEP as parts-based, which is awesome actually. For some reason, a BIM model with like plumbing and HVAC is brilliant, but that's because it's sort of like a production fidelity parts. So what you need to manufacture walls, passive house assemblies, is a production fidelity parts-based model. So that's what we do. We go back to that circle, right? And we get all the design intent, and then we're kind of just building out every stick, sheet, sometimes fasteners, concrete, insulation under slab, insulation at walls, insulation in the cavity, insulation on the exterior, sheathing for floor, deck. In this case, actual roof trusses that came and were delivered. Usually when we have roof trusses, we kind of go back and forth with the truss manufacturer so that we have actual geometry and we just know that everything is going to kind of line up. So you need that model to manufacture, but what's great is, well, the reason you need it to manufacture is you need these basic outputs, right? You need panel drawings, you need people to know what's coming, you need some coordination down here in the lower right. This is where we started to coordinate with that groin vault system that was prefabricated. And you also need installation drawings. So you need to know where your floor panels are going. You need to know where your wall panels are going. You need to know, what to expect in corners and all these details. So what happens is, and this is what we kind of figured out, is that as soon as you need that very, very high fidelity, pretty dense parts-based model for the things that are going to be fabricated, we saw these great opportunities for more than just that. And that's kind of why we took sort of what was a production model required for fabrication, and we turned it into something that we think is sort of has greater value as a really sort of holistic project coordination model, which is the SIMM model. So I'm going to try to be quick here, but I'm going to tell you about the opportunities that we right now are working on, and then maybe a couple of them that we're thinking about for the future. So first opportunity is clearly a very, very high fidelity alignment of clash detection between all of those different components. So like structural steel, concrete, MEP, we bring in, or we can create MEP content that is accurate to the plan. And then we can bring in and work with the structural engineer to find out exactly where the point loads are and where the structural steel components are. And in this case, we're going to have like an armatherm detail underneath point loads on concrete to try to avoid some thermal bridging. So we're going through and we're just sort of putting all these parts together, but then we can also kind of peel them apart very quickly. I think I'll show you when we have the model open how a parts-based model like this one, there's so much data that you're attaching to it that it actually becomes a really great way to like navigate a model much quicker than a BIM model. These are the floor trusses and roof trusses. We model them first as just very basic, just to kind of tell them, based on all this design intent, we believe this layout should look like this. If you bless it structurally, then please tell us and send it back your geometry. So we like to bring in, we don't need to create all the content. We love to create content. We also love to work with your content. So we bring in content when there is another fabricator. And I think that is another big kind of missing piece of a lot of fabrication coordination. So it's just so awesome to be able to then like have the MEP in there that came from them and then make sure they really are clear. We all agree that vertical and horizontal alignment and any kind of duct clearances, in this case, they accommodated duct work for all the trusses, really is where we want it. And then we end up with, a full build that has all the skins and we panelize it. And I'll show you that a little bit more. The next opportunity is risk mitigation and information log. So yeah, the risk, the value, I think, for any offsite fabrication from any passive house panel company is it starts with risk, and I think it ends with risk. It's all risk to me. It's like, when we were doing all this by hand, all the passive house builds, well, any builds, but especially with passive house, there's just a lot of risk going on because you're trying new assemblies. You kind of like, you're pretty good on your build, on your your building science and your thermal bridging, and you're relying on a lot of great people, but you really don't see everything. You just see everything in 2D sections, right? So with a model, you can really get your hands around everything. And so what we do is, as we build this model out, it becomes this kind of communication tool. And, it becomes like the conversation piece in our weekly or biweekly meetings. And we can just take this thing and we can focus in, in that design log I showed you. As we're modeling, we're basically cataloging where we see conflicts and we see questions and things that need to be resolved. So we grab screenshots from the model, we throw them in the design log, we call it a row item. And then when we're in the meetings, we can very efficiently, in a very direct line, just go through the design log and pull up these parts and have the team talk about them. In this case, it's me and Ilka and the two architects and the structural engineer. We also then end up having charrettes with the MEP engineer. It's really fun because, you're still doing a Zoom meeting, but you have this like 3D model. So sometimes it's better to do a hand sketch. Sometimes Kyle in particular loves to draw all over our 3D model. And he's always like, stop moving, I'm trying to draw on top of your model. But what's totally awesome is that in the Zoom meeting that is based on the design log that we came up with as we were modeling, then we're doing screen captures from the Zoom meeting and it goes right into the design log. So the design log is like always on when we're modeling. And I think that's just another kind of cool thing. This is the 3D viewer. So all of our clients have a version of the 3D viewer, and then they also get a non-editable CAD work license. If it's, if it's a good project and they're going to work with us, we get them a CAD work license. They can't draw, but they can really get into the actual SIMM model, and we hand the SIMM model off afterwards. Yeah, this is Kyle like drawing on top of my stuff. Yeah, risk mitigation and information log. It's just endless different things that we find and we have questions about and we need to work through. This is another opportunity that we really like about, it's not just our stuff, but it's just generally passive house off-site manufacturing, is that we get to eliminate the desire by somebody on a project team to value engineer out low embodied carbon. We get to just say sorry, and we do it all the time, and it feels so good. So we just say, you know what? The factory doesn't do anything but wood fiber insulation on the exterior and hemp or cellulose in the wall cavity. And these are the reasons why, and we love to show them how badass this vapor profile is. And then we say, that's the only way the factory, we actually lie and tell them the factory just won't do it another way. But that's because that's what you can do when you have a panel company that's just sticking by their guns and saying, this is what I'll do. It doesn't mean they might not tweak those assemblies, but they're only going to make it the right way. I have to go back. Another opportunity is the passive house detailing. So Ilka can take the model and she can slice and dice that thing and discover every, phantom that would have been in the sequencing. We typically do a membrane strategy. So there's a lot of leaders, and the leaders, it's all about the sequencing of the construction. So if you don't have the leaders in the right place when you go to throw a floor panel on top of a wall, or a roof panel on a wall, or whatever it is, or you have a steel beam that somehow penetrates through the air barrier, she figures all that stuff forensically. She goes through and she creates, a red line drawing, but then way more. She's really closing in on the details that become instructions for the builder or the installer. The next opportunity is trade and field coordination, which can happen in a lot of different ways, but two of the big ways are through concrete and also the structural steel. So we don't do the steel shop drawings, but we either create the content that we have interpreted and then check it against their steel, or they give us an IFC file. And on this project, it was great. We got an IFC file, we checked it against our design intent. And then these are just some little pieces. We did a 3 or 4 page kind of, these are some holes you guys didn't know about, right? And I'll show you, I think, an example in a few slides on how that works. But on the concrete, it's really, really nice because I don't know if everyone has had the same experience that we had for like 20 years, but a lot of times it's a little confusing when you're looking at like laying out your foundation between what the structural say and the architectural say. And sometimes you're almost using both and you're making a lot of judgment calls as the builder, and it just sucks. So what we like is that because this is a fabrication model, like this big house is a 7,500 square foot house of wall, floor, roof panels, and other loose parts are coming. And if they come, this foundation better be within a 1/4 inch. And so what's great is because of that, this coordination model is just what it's going to be. It's not like there's no dispute. It is what it is. As long as everybody reviews it and approves it, then that's what's going to be. And then this is cool. This is our builder on this project from Hanson Fine Building, Chris Hurl. And we were on site, and he, we were actually verifying the ideal precast walls. And I said, yeah, I got your email about that structural steel question you had. And I said, do you have the laptop? Can we go look? So I go into the trailer, and he already pulled up our SIMM model, and he navigated right down to the pieces that he wanted to talk about. And I was like, dude, you're totally gonna make me cry, because I just love that you can just use this model. When we're gone, you can use this model. So like, this sort of magnifies the level of coordination that a project like this, and even a much smaller project, could need, right? So this is a piece of steel, and this piece of steel has some holes in it. It has holes in the top flange that are going to receive that, are pretty basic. They need to receive a wood plate, but there's some blocking that's going to happen. And that blocking needs to be here because that blocking is going to hold up those trusses that were from another fabricator. So the steel's from one fabricator, the LVL is from the builder, the trusses are from the truss fabricator, but they're coming to the panel company who panelized it from our drawings. And so when that whole thing comes, it's like 3 parts that all need to come together, but they're coming from like 4 different people. And then underneath that, there's going to be panels for the exterior soffit panels that need to fit and need to have some way to work around each other. And when it's all done, that's one corner of a 7,500 square foot building that has corners like that all over the place. So there's just a need for coordination, and we're just giving you one way we do, but all around the board, we need to figure out ways to like get design intent married to parts. That's kind of, it's kind of like our thing. Here's the opportunity that is the most fun for my brother, and I think also for Ilk and I, and that's the data attachment. So the thing that's cool about this, we use CAD work to create this model. And what's cool about CAD work, and I mean, I know you can attach data to BIM models, but when you have all these parts, thousands of parts in a model, that, that sounds like a lot of work, but a lot of them you can populate, pretty streamlined. But every single part, you can assign unlimited amounts of different data attributes. And then every one of those data attributes becomes a search. It's almost like a thread, right? So you can now say, okay, I'd like to activate all the parts that are spruce pine fir. They have a red dot and they are 6 foot 2 1/4 inches long. Boom, 2 clicks, and I have all those parts. If I wanted to say, I'd like to see all the concrete, all the PSLs, and all the armortherm, boom. So that's what I was trying to say about the data attachment is awesome for outputs for like takeoffs, orders, pricing in the field, and also especially in the factory. The factory needs obviously, parts lists and everything. But what's just awesome is that when you put the data on there, you don't want to put data on there that's not necessary. But if the data can deliver value and you put the data is this like thread to basically navigate your model. The more data, actually, the easier to navigate the model. So, so we've been talking about, I keep talking about factories, right? But what's really cool, we also realized is this other opportunity is that the shop drawings and the panel drawings that we create from this content would also be, and will also be really, really good for anybody that has a warehouse and a nail gun, or somebody that has a warehouse and a nail gun that maybe thinks next year they're gonna have a good year and maybe they might want to buy like a Humdinger, or like anywhere in the middle, right? Like the place between Blueprint Robotics at this insane investment level and the guy that has 5,000 square foot with a nail gun, there's about 150,000 different different types of investment and risk and excitement that are out there for the grabbing. And what's awesome about a parts-based model is it can serve every single one because it has the thing you're going to build and it can deliver shop drawings or machine files or 3D files. So this is a project in Baltimore we're very excited about. It's the Baltimore Community Land Trust, and it is it's affordable housing. I don't think they're calling it technically affordable, but it is for underserved community, and I know their budget is very affordable targets. And the idea is that in this region, in this area, the people who build and also own are going to, all the equity stays in the community, in the neighborhood. So on this project, the idea is we are contracted to first do like a feasibility model. So we're doing the model. We're going to be able to create pretty good takeoff numbers for them on, there's a 6 unit and 2 unit buildings, and we'll do the feasibility models, and then we'll create all the shop drawings. And the idea is that if it all works, they will fabricate in their warehouse, and they're bringing in from Carver Vocational School, they're bringing in some students to come in and help build panels and learn about construction tech. So we're really psyched about this. Actually, I wanted to say the architect that brought us this is Jason Neal and Melanie. Where is it on here? The one who runs the whole program. So anyway, awesome program. You guys should definitely check this out. There's some stuff online about it. We're happy to send you some information, but we're very excited about it. And this is sort of getting in early on the project. These are a couple of the 2-plex and then the 6-plex. We're just kind of starting out, just doing some really basic kind of rough modeling. And now we're to a point where I'm actually a day or two late. That was one of the deadlines I was working on, but we're going to feed them now takeoff information that is not ready to build, but is pretty damn accurate for all framing, all TJIs, all LVLs, glulam beams, plywood. They're hopefully going to do our XP10 open wall assembly. So there would be either a CDX with a membrane or possibly an AC plywood taped, cold roof on top. So they're going to have takeoff for all the sheet goods. They're going to have takeoff for all the hemp bats, and dead accurate takeoffs, which is really nice. Takeoffs for the Styco exterior insulation and foam insulation where required, and then TJIs. And then they're actually going to get takeoffs for the drywall. And what we're doing is we're working on so that when we have all the rough openings that kind of help us create framing, we're attaching data to the rough openings so that we can also give them information on tapes and membranes and sealants related to like window and exterior door installations. So that was a lot of stuff. And now I'm going to show you something completely different, and I'm almost done, I think. Yeah. So now I told you that we have these cool partners in Stoltz. When we connect to cool partners, it makes us look cool. So that's why we were always looking for cool partners. And these guys are pretty freaking cool. So they've been importing, and their plan is to actually, they're in development right now, and I'm hoping that next year they're going to be manufacturing from small diameter timber, glulam and CLT components in Montana, which is cool. So we work with them on their projects in the West Coast or out West, and we also can work with their stuff if it imports into like Baltimore, Philly. And so what we started really getting into is not just the CLT and some of the different torsion box and different products that are engineered CLT type products, but we started getting really excited about the hybrid because we've got a lot of experience now with light framed, and we can kind of deliver a light frame design to factory kind of offering. So this is a project that we may or may not do in New Jersey. It's these little mini cabins. There's 21 unit motel, and so this is like kind of ready for battens. If I want to just kind of take it apart, so I take the Styco, the exterior layer off, I go to Styco Therm, and then I go to CLT walls, and now I'm taking off the 3-ply material. It's like a thin CLT. It's a really, really cool, huge, like a really long format plywood, kind of European plywood that you can throw down. You can get it like 15, 16 feet long. It's ridiculous. This would be all, what you're looking at there would be all pre-cut. dovetail housed, very few fasteners. It's a decoupled, thermally decoupled. So you can see right there, there's insulation underneath. So the whole cantilever is decoupled and has a very small thermal bridge profile. Take off those, we've got post and beam. All of this comes from one manufacturer. And then we've got these portal frames that we were able to do the CLT. Then we've got, boxes, walls, and take the deck off. We've got, either conventional or a pre-cut deck. And now we have this deck, and Ilk and I were like, well, what about if we just put, like one of our wall panels on it? So we just took the deck and then we put some of our wall panels back in. And this is the framing for our closed wall. Inside, we have the sheeting on the inside on that wall. Insulated, there would be cavity insulation and the therm and the Styco. And then we just basically put the exact same CLT components back. So the only thing really in the building that's changed is the walls. And then we throw the post and beam back on. This all came in. So really now we have 2 vendors that have delivered the whole building instead of 1, right? So the sequencing is really pretty sweet, especially on a 1-story, but even on a 2-story, not really bad. And this kind of thing could be very easy for any builder to put up. I mean, we kind of map it out. Bring back in the thermally decoupled roof, throw on the 3-ply, and get your beer. So that's the presentation. And then did you want to wait until I show you the model, or what do you want to do?
I think I want to clap.
Yeah, I want to clap. I want you to take a bow. Wow. Steve, even better than last night.
Yeah, that was terrific, Steve. Thank you so much. What an
Steve, Steve, your audio was off. Can you start again from the top?
I think my wife wishes my audio was off a lot more often.
Love it. Love it. Just like your renderings, it's TMI, brother. I think we could go to the modeling, right? I think we could jump right in if you want to have a swig of beer and let everyone stretch their limbs and go for it.
Steve, I've got to say while you're doing that, I always thought the takeoffs and coordination down to the stud was fun, but takeoffs down to drywall and tape? Seriously, what is next? The number of nails? Lunch orders for the crew? Does it make breakfast?
Well, for CLT, we will definitely be modeling fasteners. You have to sort of play with like the memory, the size of the file. But like in timber framing, a lot of times you're modeling fasteners because you kind of have to. But yeah, it can get a little weighty on the model. But the thing about it is they're costly. These fasteners are costly, and so if the model can deal with it, it's a very good idea, because then you just have a much more accurate takeoff. When you have it in there, you can run a list on it. And then there's some coordination things that I didn't talk about in the presentation, but I could talk about when we're looking at the model. Remember we were talking last night about the future builder. So the running fasteners in the model is actually, it's worth thinking about for certain projects for sure. So this is not the model, but I just was going to really, really quickly show you some of the other outputs just so you can see what an actual set of geometry review set. So
sure, go ahead and share your screen again.
Oh, and also, wait a minute, there's one more thing I also wanted to say, that I think David is in the audience and Ilka is definitely in the audience. And I would love it when we get to questions and answers. Those guys are brilliant, and it would be awesome if you guys have some questions for them.
Well, David is all over the chat, so I am trying to figure out what I still need to queue up for you and what has been answered by him, because he's all over it. So thank you, David, in advance. Okay.
So the outputs, so this is the model that you were looking at for some of that stuff. And this is the 7,500 square foot certified passive house in Gladwin, which is sort of a affluent neighborhood outside of Philadelphia. And it's actually in production at New Energy Works, and they're going to start to install floor panels next week, which is crazy. I'm going to come back to the model, but I wanted to show you really quickly the outputs. So there's sort of 2 drawing outputs. One of them is a geometry review set. It's like a shop drawing, but it's that wrist bucket thing. This is a really huge piece of the wrist bucket. So if this thing doesn't really tell you a lot, then there's not a lot of value in it, because when you have a building with these many parts in it, if you don't get to see those, like if you get like 3 or 4 building sections, then everybody just has a lot of risk going on. So I'm going to blast through this. So I'm sorry if you get a little dizzy, but basically factory scope on the right, builder scope on the left, coordination drawing, you saw that for the foundation. This is builder scope because they did the walls inside. So they didn't need this, but they could get panel drawings from us if they felt like it, but they're going to site build. So this is the first floor. This is like the first wall plan drawing. So pretty much because you've modeled precisely every stud and every piece of insulation, and this is the service cavity on the inside and the zip and everything, you're able to now extract dead accurate sections, cuts, and everything. So the wall panels are in there. We still have all the door information, the door tag information. So it's a pretty easy set. Everything, every page in here is color coded and it's hatch color coded, with the idea that we're trying to limit the annotation burden, not only for us, but also for the interpreter. So that seems to be working really well in the factory and also for the reviewers, like the architect and builder. So I'm just going through, this is like the next floor. Now we're getting into like the structural floor plans for trusses. And so we had that MEP model, and now this content actually we were able to generate from the MEP just being in the model. Now we've basically told the truss fabricator we need a 20 inch by 14 inch clearance, centered vertically or aligned top bottom. So we're just making sure everybody is cool on trusses. And then we're going to do that with the next level. And then we're going to do the roof. And now we get into elevations. And so this is the same elevation, shows the skin, exterior skin, and then shows you the framing and just absolutely everything about that rough opening, including like floor ceiling doors that some of them were set low. So like this door is set a 1/2 inch low, cut into the subfloor. This one's not. So like you just have to, everything has to be perfect. There was a very expensive window and door installation, and we just can't, Holzraum System doesn't carry that level of insurance that we want to buy $200,000 worth of windows and doors. So we just need to make sure that we tell everybody this is what you're getting. So look at it and make sure it's good. But we like it because it seems like it's pretty easy to see the things that are critical. You always can, your eyes drawn to critical plate heights and ROs. Now we're getting into building sections, and the building sections, again, these are exactly what these assemblies are going to look like. There's not like a 2D detail that happens at one spot. This is what's happening, and these are dead heights that we're going to hit. And then we can use those details and blow them up a little bit, get into more sections, threshold conditions and window conditions. We can now really get into exactly what's happening at foundation. And so it looks like a lot of work, and it is a lot of work, but a lot of it comes because we put the model in. If you build the parts, then you can extract these kinds of outputs really quite quickly. We're not like, I know when I worked in Vectorworks, I would have a model and it was pretty coarse, and I would get like these great sections, and I would look, I'm like, I got to draw all the CAD on top of the building sections. Like I know that happens in Revit too. You're basically drawing in 2D on top of your 3D section. That the only thing that's been drawn after the fact here is just basically any additional annotation and dimensioning. So that's what we really like about having those parts in there, because those parts can deliver some geometry. These are some window install air sealing details. And now we're getting into the parts that are going to be necessary for fabrication and also for install. So these are the soffit panels. These are parapet and exterior wall. And then these are some panel connection details. And then this is the stuff I was telling you that Ilka does a great job of just kind of really tearing this thing apart and finding areas that need specific explanation, some really weird stuff that she found that just needed to be called out. And it's great because we go through this not only with the architect, Kyle Macht and Paul Macht they're very, very, these are like serious passive house architects. They're some of the best we've ever worked with. And yet a building like this had us all just like, holy shit, like there's so much things that could go wrong here. So I think that we all really enjoyed having those parts to sort of tell that story. And for Ilka, I don't know how she does it actually. She just knows where to look, but now she has the tool, to really like get her parts in her hand and figure it out. So I think that's most everything for that. And now this is the model. So I wanted to show you the model because it sort of starts with, just basic CAD, right? I mean, we bring in an IFC file, and or we can bring in any model pretty much, but typically it's just like in design intent, it's telling us what you're looking for. But a lot of times when it comes in as an IFC file, it's just blocky in weird ways, mostly because of the parametric walls. So like it's a block and we don't know exactly where that block ends up, and sometimes maybe it includes the facade in the block, but the facade is almost one of the last things always to really get nailed down. So that doesn't help, right? So we actually find that, which is kind of cool for people who are still drawn in 2D CAD, is that we can almost build almost as well from 2D as from 3D, but 3D obviously helps us to visualize it. So we're just kind of building out. We take the sections out, but usually there's some sections in here that we're kind of extruding out and building through. And then we just start, just kind of building this thing out. And, we're able to really look at what exactly, or we did a weird double plate. Kyle came up with this cool double plate, but we actually have insulation underneath the plate. Like I said, there was some armatherm detailing that we ended up going through. First floor level. This is actually from before I had all the truss geometry in there. Second floor level. So we're creating these volumes, and then eventually we're going to replace them with axial framing. And here's some of these are actually panelized trusses. And so what's cool is at this point you're looking at a fully blown out production level model, and so everything's panelized. So if I want to look at that panel, that's the panel, right? And that's true if I'm looking at like exterior walls. I can grab a panel, that's the panel, right? I want to look at the panel, I want to see what's in it, I want to find out exactly what part. If I look at that one part, you can't see it because you're screened, but there's data attached to every single part. If I want to go back and look at the exterior walls, then I can just click on a wall. Like there was a couple weird issues that we were looking at. So we had a meeting on some of these parts. There was some weird stuff happening. These are some tricky spots in this building. This whole thing right here and this one are just weird because the air barrier is doing strange things. Or this is where Ilka found this steel beam right here that's like kind of blowing into the air barrier. And so we can just kind of take these, grab things, and boom, I need to look at the panel. And now I'm looking at the panel, right? It's just crazy. And then what's also very cool is I go back into the truss panelization, and when we do this MEP charrette stuff, whether I have trusses on or walls on, I could also bring in some interior walls. You can start to build out the content that you care about. And now I've got MEP and it's sitting inside, and now I can do a horizontal and vertical alignment. See what's happening underneath. I can look from the side. I can isolate what I want. It's like having your hands on the parts.
Steve, before we end up at the end, can you talk a little bit more in detail about the design log that you create when you're in a meeting with people and you're looking at this together?
Yes, just give me 1 second. I'm going to go get one. Okay. So this is the one for this project, and it is just like super, super, super crude. It's a freaking Google sheet, right? But it is set up so that you can filter along an MEP, structural, architectural, Passivhaus, insulation, or custom issue. Like for our CLT projects, there's just a whole different set of categories that make sense. Actually, on one of our projects right now, they're running their project on AC360, which is a great collaboration platform. And when we ran through the building, one of the meetings with the builder, we showed them this. We said, we're going to be communicating our issues with this, but don't worry, we'll let you know when we have an issue. And he loved it. So he said, well, we have to be able to do that in AC360. So for like a week, we all were looking to try to figure out how to do it in AC360. And then eventually he's just like, I'm just going to use your log. And so we added another column basically. So he has his issue. So he's using the same log, which is nice because when we're in the meetings, he can use it. And then we turn it over to my stuff and we can use it. But it's very simple. And the idea is you have a design issue, who do you need it from? Who's the player that you need to help on? When did you sign it? When would you like it? If it's done and you're in the meeting and you go through this and it's resolved, then it gets called resolved. And then over here, if there's a screenshot associated, you're basically saying there's A, B, C, D screenshots, and you go to the screenshots page. And basically, this is the kind of stuff that we're pulling while we're designing or in Zoom meetings. Sometimes it's from their plans, sometimes it's from our model. And if you just kind of go through over the course of this project, you know, you can sort of see every single one of these is issues that could have been a headache. I mean, every single one would have been a headache. And so we're just going through and finding issues, fixing them. Usually we can fix them in the phone call or the Zoom. And then we just hope we got them all. And then we go to production. And so far we haven't gotten burned yet. So I think that's it, really. I mean, I think you saw the model, and yeah, that's it. I'm going to stop sharing.
That was beautiful, Steve. Thank you for that extra explanation.
Yeah. Thank you very much.
Absolutely. And I know you might have a little slide in there somewhere about someone who maybe inspired you along the way.
So my mentor, it wasn't really hard to figure out. I've had lots of mentors, and like I've been really lucky with some really awesome craftspeople. When I was doing my carpentry apprenticeship, I had some just really, really incredible like metal workers and cabinet makers. So I was really lucky. And anytime I saw somebody that was brilliant, I was like, I got to go follow that guy. But my dad actually was number one, till like literally the last, you know, I think the week before he died, he was like still like just turning me on to new stuff. And so he was Dave Hessler, was an electrical engineer, absolutely brilliant, worked for NASA, Bell Labs, was way into computing, and like really, really early on. You know, when I was like in the 70s, when you know, Space Invaders was like the first kind of arcade game, my dad told my brother and I, instead of buying it, he handed us a book on programming. He's like, there's the code, go type it in and you can have Space Invaders. So he was kind of force feeding us on some stuff in a really fun ways early on. Eventually he had a job, a side gig, and he showed me one of the first versions of AutoCAD. I think I was in high school maybe, and I didn't really do a lot with it, but it just kind of stuck in my head. He also was the guy that turned me on to woodworking. He, you know, in our basement, which was like Santa's helper, kind of crazy Santa's workshop place, where you would just, anytime you needed something, you just had, well, we got to go to the basement, we're going to mill that. And like he had steel end mills and woodworking tools and electronic stuff and lasers, and like it was just insane. So yeah, we were in the basement one day. I think I was like out of college, and he hands me this like Stanley jack plane from like the 50s, and he's like, oh yeah, this is your grandfather's. Your grandfather was a cabinet maker, and his father was a hobbyist cabinet maker, and then so now I have like 7 pieces of beautiful walnut furniture that I never even knew it till I was in college. And I kind of had been getting a bug for woodworking out of nowhere. And so yeah, he hands me this jack plane, shows me how to like join a piece of wood. And then that's when I just went crazy on woodworking and timber framing. And I kind of got into all that and furniture making and everything. But the other thing, so what happened was I found when he would turn me on to this, you know, like the computers and the CAD and everything. When I got out of college, I don't know why, but I just thought, my brother was a programmer already at that point, and I thought for some reason that I needed to learn, maybe I should teach myself programming. I didn't have a computer, but I got a book on it. And I was like, I don't know why I need to know this, but I think I should know this. So I learned like basic programming or something. And so fast forward, I'm doing my carpenter apprenticeship with a restoration company, and I get a call from this guy, Ted Mara. He was putting together a company called Pecopson Timberworks near Philadelphia. It was the #1 first 5-axis timber framing processing plant in the country. And he knew that I was into CAD, and he knew that I like was a geek on programming a little bit. And so he hired me, and I ran that machine for a year or two. And then eventually I was bored, so I said, I need a CAD work license. And so when the parts are running, you know, you have like a timber frame post with a whole bunch of joinery on it. It could take like 45 minutes to run that part. And I was just bored silly, and I would quit. And he said, well, how about if I get you CAD workstation? So I learned CAD works while I was watching parts run. And then I quit again because I was like, I got to go out in the field. And then he said, well, what if I let you go work in the design department. So then I did that, and I started designing timber frames. And then I quit another time, which was awesome. Quitting 3 times is definitely good for your income. And then I ended up running their design department for a while. And then we had like 4 different CNC machines, and we had a planer on board, and then we had our own steel shop. And that's when I kind of learned a lot about like fabrication, you know. And so that's really when that's when I started thinking about what was missing, you know, in this like siloed kind of design thing. So anyway, thanks, Dad. That's my mentor.
Everybody, if you have the ability to unmute and raise a glass to Dave Hessler. We're a big fan of your work, Dave Hessler.
Dave Hessler.
Cheers, Dave.
Cheers.
Cheers.
Cheers, Dave.
Cheers. Cheers. Really awesome.
Cheers.
I'm going to quit 3 times too, Steve.
If you could mute yourselves, ladies and gentlemen, Zach has the microphone.
All right, thank you. This is what an amazing presentation this has been. Thank you very much. Everything that we do at the Accelerator happens because we have supporters, support from sponsors. None of this would be going on without the support. So a big shout out and thank you to these fine organizations. Our founding sponsors are 475 High Performance Building Supply, Baxt Inqui Architects, Mitsubishi Electric Train HVAC US, Partel, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, RDH Building Science, Rockwool North America, Stocorp, and Zola Windows. Our champion sponsor is SIGA, and our stakeholder partner is NYSERDA. Patron sponsors are Aero Barrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Inotech Windows and Doors, and US Engineered Wood Teasted. So thank you, thank you, thank you. So our podcast episode this week is one that is very special to me. I had a great conversation with Bomi Jung of Topside Advisors. She was recently at New York City Housing Authority, or NYCHA, and we talked about the impact that Passive House can play in affordable housing and also in delivering climate justice. It's a really great and super interesting conversation with a very smart person, and that I'm referring to Bomi. Tomorrow, speaking to smart people, we've got Melissa Furukawa on the show at Happy Hour, and she's going to be talking about insights as a Passive House certifier. So we're going to get geeky with the model tomorrow, so don't miss that. I know that'll appeal to a lot of folks here. Next week on Construction Tech Tuesday, we've got, I love this photo, we've got Daniel Kress of Smart Plus Academy. Next week is like Down Under week, because Daniel Kress teaches. He's one of the instructors for most of the, or at least half of the practitioners of Passive House in Australia. So he'll be talking about cooling in Passive House, talking about delivery of Passive House in a hot climate. And then on Wednesday, Talina Edwards, the beautiful Owl Woods Passive House, won a bunch of design awards. She'll be presenting at the Happy Hour. Finally, Thursday of this week, so in 2 days, we've got our Resilience in Canada Summit that we're presenting in coordination with Passive Buildings Canada and Passive House Canada. It's going to feature 3 amazing projects that are delivering resilience to communities across Canada. Really interesting stories about the communities these projects are being built in or were built in, and great stories about the connection with Passive House. So I'm going to include a link right now in chat, and that is it for me. Thank you.